So today we will do the Verilog coding for a multiplexer. So first we create a source in the Verilog and create it in the Verilog module document. Give it a name, MUX. Then for a MUX, what we are doing today is a 4:2 MUX. That means it will have 4 inputs and it will have 2 data selector lines. So you for 4 inputs you have to create an array of 4. So we have taken this as 3 and 0. So with an array of 0, 1, 2 and 3 we will get 4 inputs. Next, for the data selector lines we will select, we need 2 inputs, so we will take an array of 1. We'll name this A, we'll name this S, and we need an output C. So this is the file. Now we'll use behavioral modeling for this, so we always start with this keyword always @s. S denotes the data selector line which you will be using in the input, which you can see here. This is the S, that is the selector line. And behavioral modeling, you always write begin after you write always. So begin if S so what this basically means is that when you give an input of 0 0 to S, the following condition will get executed by the command program. Now I am writing the another condition. Which means that if the data selector lines gives 0 and 1, then this will get now there will be 4 conditions for this data selector lines, that is 0 0, 0 1, 1 0 and 1 1. This is the third condition. Else, that is the last condition. So what this basically means is that whenever we have given an input of 0 0 to the data selector lines, the output will be the first input in the MUX. A MUX 4x2 MUX will have 4 input and 2 data selector lines. So the first input will get executed when we give the data selector lines as 0 0. The second input will be executed, that is the second input, when we give the data selector lines as 0 1. So and always you have to put semicolon. So now we'll verify this. We'll check for syntax errors. So you have to go to select this file. You have to go to simulation and check for syntax errors. Now there is an error in line 21. So this is the thing I missed. So output you have to take reg. Reg means it is being registered output. So every time an output is there, the previous output of it will go registered. So you have to remember that while doing behavioral modeling. So I have made the following changes in the code and I will rerun this. So we'll check for the behavioral modeling. once the syntax error is getting, so first we have to get a tick over here. It means that the syntax is correct, then only we can initiate this behavior modeling process. So we are using this naive approach of forcing constants. We take any random we can take any value, and I'm taking a constant as 0 1. Then if you press here to run, that means I'm getting a 0 value. So you can try this for various test cases of your phone. So now I'll show you how to see the representation of this. So whenever you want to get the RTL schematic, after simulation you have to put it in implementation mode. In implementation mode, you have to right click on the file which you have selected and put it as set as stop module. You have to continue this, and you will have to see view RTL schematic. So it will form the exact circuitry of the code which you have written, so that you can get the desired output which you want. So you will get this window. Then you have to say to start with a top level block. So in this circuitry, so this is the Verilog schematic. If you double tap on this, you will get the exact representation of how it is. So that is how your circuit is going to be. There are going to be 4 input lines, and there is going to be selection line. Selection line is a bus of 2 inputs. So if you double click on this, you will see the various lines and data pins. This is data pin 3, this is data pin 2. So this is a bus of 4 inputs, and these are 2 selection lines. So based upon what you give here, you will get one as the output. So this is how you implement MUX or a multiplexer on a Verilog.